Okay, we're going to do a new problem. We're going to have lots of problems for this section. Find the lowest cost. To make a storage container. Okay, find the lowest cost to make a storage container, and I'm going to give you some details. To start, let's draw the storage container. Okay, there's the bottom. Then we put parallel sides up. Oops, a little straight there. Then parallel to this bottom, we make the top. Then we connect the corners. Okay, so there's our storage container. Now this storage container has an open top. So I'm just going to color in the sides. It has an open top. Okay. Now what they do give us is that the width, we're going to call it W. We know the length is twice as long as the width. And then here's the height, which we don't know. We're going to call it H for height. They do give some information, and that is the volume of the storage container is going to be 20 meters cubed. All right. Now to make it, the bottom piece is going to cost $15 per meter squared. Okay. The sides are going to cost a different amount. They're going to cost $12 per meter squared. Okay. All right, what you're going to find in these problems is they're going to give us some information, and we'll eventually find one variable by using the different information they give us. So far, what do we know? We know volume equals length times width times height. So let's put in what they gave us. They said the length is twice the width, and here's the height. What else did they give us? They said the volume's 20 meters cubed, so I'm going to put 20 out here, 20 meters cubed. All right, so simplifying, we have 2w squared h equals 20. Now what we're going to do for this is we're going to solve for h and use it later on. So dividing both sides by 2w squared, we have h equals 20 over 2w squared, which is 10 over w squared. So we're going to utilize this later. Now with what? They gave us two things. That's my dog hacking away. Let's see. They gave us volume and they gave us cost. So let's do a cost function. What do we know about the cost? We know it's $15 for what? $15 for the bottom. So the bottom is, the area is 2w times w. So 2w times w. That's the cost for the bottom. Okay. Now we're going to add to that the cost of the sides. Well, we have these two sides, the front and the back, and the bottom is 2w, and then we have h. We have two of those. So two front and back to start, and the area is 2w times h. All right. And what do we also know about that? We know that is $12. Okay, we got to keep adding because now we have the left side and the right side. We have two of those, and the area for the left and the right side are WH, and that also costs $12. Okay, so let's continue with this. We have 30W squared. Here we have 2448 WH. 4 times 12 is 48 WH. and then we're adding here 24 WH. So altogether, our cost function is going to be 30W squared plus 48 plus 24 is 72 WH. Now, we can't do anything because we've got W's and H's. We've got to make them all W's or all H's. Well, over here, we solved using the volume. H is 10 over W squared. So let's put that in here. 30 W squared plus 72 times W, 10 over W squared. Okay. So let's simplify this. 30 W squared plus, we're going to have 72 times 10 is 720. And this W cancels out the W squared, and we end up with 1W. Okay. Now this is really nice. We actually have one function with one variable. And the question is, find the lowest cost. So we're going to take the derivative of this function to find the minimum. All right, I'm going to erase this. Give me a moment here. Okay, so we want to find the critical numbers. So we're going to take the prime. All right. Our prime function is going to be 60W, and when you figure it out, it comes out to negative 720 over W squared. Okay, we're going to set that to 0. Now we're going to solve for W. This minus sign we're going to add to both sides, so I'm just going to bring this over here. Okay, now we have to solve. What are we going to do to solve? Well, I'm going to multiply W squared on both sides. So I'm going to multiply it here to get rid of that. I'm going to multiply it here. So we have 720 is 60 W cubed. Okay, we want to get W alone. So we divide by 60 on both sides, and we get 12 equals W cubed. Oops, that's a cubed. We're going to cube on both sides, and we get the cube root of 12. And this is in meters. And what do we find? We found that this right here is our critical number. So what are we going to do with that critical number? Well, we're going to find the relative max and relative min. Okay, so we're going to look for double prime. See, double prime of W. All right. Now, when we figure this out, the derivative of this is 60. And when you do the derivative of all this, I'm just going to write it out. You can do that on your own. 1440 over W cubed. Okay, now we know that we're looking at a width, and widths are positive, all right? So we take a positive width, and it's not going to be bigger than 60. So we know all of this is going to be greater than 0. So if this is greater than 0, what do we know? We know it concaves up, and so we're going to have a relative minimum. All right. So where do we have a relative minimum? We put it in. We're going to put C of cube root of 12 into the function. And this is our original function. Okay. We put it into the function. We'll go over here. And it comes out to be approximately $471.73.